NENOMATICA, where mathematics meets YouTube excellence. We display the example and the given equation. Step 1. Determine the domain. A logarithm is defined only when its argument is positive. Therefore, every argument we see must be greater than 0. Step 2. Rearrange the equation by adding terms to both sides. Move negative terms across the equality so they become positive. Add log base of g of x to the left side, and add log base of k of x to the right side. The equation becomes log base of p of x plus log base of g of x equals log base of f of x plus log base of k of x. Step 3. Apply the product rule for logarithms. The sum of logarithms with the same base equals the logarithm of the product. Combining each side gives log base of p of x times g of x equals log base of f of x times k of x. Step 4. Use the one-to-one property of logarithms. If two logs with the same base are equal, then their arguments are equal. Therefore, p of x times g of x equals f of x times k of x. Example. Solve the logarithmic equation exactly following the shown steps. Step 1. Determine the valid domain of the equation. The argument of every logarithm must be positive. So we write x minus 2 greater than 0, 2x minus 7 greater than 0, and x plus 2 greater than 0. Solving gives x greater than 7 over 2 as the most restrictive condition. Step 2. Rearrange so logs are on corresponding sides, and rewrite the constant 1 as a logarithm. We use the identity k equals log base b of b to the k, so 1 equals log base 7 of 7. Move the negative log base 7 of 2x minus 7 to the left, and place 1 as log base 7 of 7 on the right. Step 3. Use the product property of logarithms. The sum of logs equals the log of a product, so we get log base 7 of x minus 2 times 2x minus 7 equals log base 7 of 7 times x plus 2. Step 4. Since the logs have the same base and are equal, their arguments are equal. That is, if log base b of a equals log base b of b, then a equals b. Write the equality of the arguments and expand. Collect like terms to reach 2x squared minus 18x equals 0. Divide by 2 to match the displayed step x squared minus 9x equals 0. Step 5. Factor and solve. Use the zero product property. Factor x out to get x times x minus 9 equals 0. Therefore, x equals 0 or x equals 9. Step 6. Check candidates with the domain x greater than 7 over 2. 0 does not satisfy the domain, but 9 does. Hence, the solution set is D equals the set with element 9. Example. In this walkthrough, we will exactly follow the written steps to solve the equation. Step 1. Determine the domain of the logarithms. For a logarithm, the argument must be positive. Now write the inequalities for both arguments. Step 2. Write the original equation again. Move the term with minus 2 log of x minus 2 to the right side. Step 3. Apply the power rule to 2 log of x minus 2. Then combine the sum of logs into a single log using the product rule. Step 4. Use the one-to-one property of the logarithm to equate the arguments, then clear the fraction. Step 5. Expand both sides, as in the written solution. Step 6. Move everything to one side to obtain a quadratic equation. Step 7. Factor or use the quadratic formula to solve. Step 8. Check the solutions against the domain x greater than 2. The only valid solution is 7. Therefore, the solution set is the set containing 7. Step 1. Determine the domain of the logarithms. Each log requires its argument to be positive. Say, x plus 3 is greater than 0, and x minus 1 is greater than 0. Therefore, x must be greater than 1. Let's visualize x greater than 1 on a number line. Step 2. Rewrite the constant 2 as a logarithm with base 4. 2 equals log base 4 of 4 squared. Step 3. Apply the quotient rule to the right side. Log base 4 of 4 squared minus log base 4 of 8 equals log base 4 of 16 over 8. Step 4. Simplify 16 over 8 to get 2. Step 5. Use the product rule on the left side. The sum of logs equals the log of the product. Step 6. By the one-to-one property of logarithms, if log base 4 of a equals log base 4 of b, then a equals b. So left argument equals right argument. Step 7. Expand and rearrange into a standard quadratic equation. Step 8. Solve the quadratic using the quadratic formula. Here a equals 1, b equals 2, and c equals negative 5. That gives x equals negative 1 plus or minus the square root of 6. Step 9. Check the solutions against the domain x greater than 1. Square root of 6 is about 2.45. Negative 1 plus square root of 6 is about 1.45, which is greater than 1, so it is valid. Negative 1 minus square root of 6 is about negative 3.45, which is not greater than 1, so it is extraneous. Step 10. Therefore, the final solution set is the single value negative 1 plus the square root of 6. Example. We will solve the logarithmic equation exactly following the given step order. Step 1. Determine the domain. For any logarithm, the argument must be positive. So we require 2x plus 1 greater than 0 and x minus 2 greater than 0. Step 2. Apply log properties. Use the product rule on the left and rewrite 1 as log 10 and 2 log 5 as log 5 squared. Step 3. Combine the logs on the right. Log 10 plus log 5 squared equals log of 10 times 25, which is log 250. Step 4. Remove the logarithms using the one-to-one property. If log of a equals log of b, then a equals b. Step 5. Expand and bring everything to one side. 2x squared minus 3x minus 2 equals 250. So the quadratic is 2x squared minus 3x minus 252 equals 0. Step 6. Apply the quadratic formula with a equals 2, b equals negative 3, and c equals negative 252. Step 7. Compute the discriminant. 9 plus 8 times 252 equals 2025, whose square root is 45. This gives x negative 252. Step 7. Compute the discriminant. 9 plus 8 times 252 equals 2025, whose square root is 45. This gives x equals 3 plus or minus 45 over 4. The two roots are 12 and negative 10.5. The domain required x greater than 2, so the valid solution is x equals 12. The provided form for the solution set is shown, and we also display the simplified value. Summary. We will solve the equation exactly as shown in the provided steps and in the same order. Here is the problem. Step 1. Write the domain conditions that each logarithm argument must be positive. We will list them in a single group display, and then intersect them to find x greater than 2 dot from the first. X squared minus 1 greater than 0 implies the absolute value of x greater than 1, so x greater than 1 or x less than negative 1. From the second, x minus 2 greater than 0 gives x greater than 2. From the third, x plus 2 greater than 0 gives x greater than negative 2. Now, apply the product rule of logarithms to combine the two logs on the left into one. Since the bases are equal and the logs are defined, we can equate the arguments. Next, expand the product on the left. Move all terms to the left to set the polynomial equal to 0. Factor out x. Set each factor equal to set the polynomial equal to 0. Factor out x. Set each factor equal to 0 to get the candidates. From x equals 0, and from the quadratic x squared minus 2x minus 2 equals 0, we obtain 1 plus or minus square root of 3. Finally, check the candidates against the domain condition x greater than 2. Only 1 plus square root of 3 is greater than 2. Square root of 3 is greater than 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.